Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Hi. How are you guys doing? Good. Hopefully, everyone is doing good. Hi. So I think I'm gonna wait until 12:03 and then we will start with a new chapter. So sekarang semua orang cakap tahniah kat diri sendiri. Tahniah dah habis 7 chapter, tahniah semua orang. So we got the last 3 chapters to go. So we have chapter 8, chapter 9 and chapter 10. So the last 3 chapters, those are very crucial to our exam actually, because our exam really dia banyak markah untuk chapter 8, 9 and 10. So be extra careful and do make sure untuk pay more attention to the lecture as well as the tutorial as well. Okay, so now chapter 8, limits and continuity. So in chapter 9, we have differentiation. Chapter 10, we have application of differentiation. Okay, so let us start. By the way, I do love the color very much. Check gede-gede color dia. Okay, next. Right, so limit and continuity. So basically we have 4 hours. So I'm going to spend around 4 hours for limit and continuity. So basically for lecture 1 and lecture 2, which mean today and next week on Sunday. So we are going to spend the time to do 8.1 limit. So we are going to learn about what is the definition of limit, what are the properties, what are the methods to calculate the limit, what is known as the one-sided limit, how to test the existence of limit, and what do we mean by infinite limit and limit at infinity. How to calculate that actually. Okay, so that is for the first and second hour. For the third hour, we are going to spend 1 hour to calculate the asymptote. So when we are talking about asymptote, it simply means that we need to know how to calculate the vertical as well as the horizontal asymptotes. So we have 2 types of asymptote, the vertical and the horizontal asymptote. So we're going to learn them further in lecture 3. In lecture 4, that is the last part for chapter 8, which is the continuity. So in 8.3 continuity, we are going to discuss about the continuity of a function at a certain point, and then we're going to see whether does the graph continuous or not at that point, of course. Okay, so limit and continuity. So this is the first lecture. We are going to do 8.1 limits. So I guess I'll do some example and then I'll give you some time to do the other example as well. Tapi cantik slide dia. I like. Okay, so the limit outcome for today, at the end of the lesson, students should be able to. So the first one, you should be able to state the limit of a function as x approaches a given value, which is the limit as x approaches a for fx equal to a. So we have to state that one. And then we have to apply the basic properties of a limit. So when we have a plus, what can we do? If we have a minus, what should we do? If we have a multiplication, if we have a division, what will happen? So those are the basic properties of the limit. And then the third one is to find out the limit as x approaches a for fx of the limit as x approaches a for gx, when the limit for x approaches a for fx is equal to 0 and the limit for x approaches a for gx equal to 0. So that means we have a rational function. So we have a function, and when we simply calculate the limit for our numerator and our denominator, so surprisingly, or not really surprisingly, when we substitute the value of the a for our numerator and our denominator, we are going to end up with 0 over 0. So once we have 0 over 0, there are two methods to solve them. So we can either use factorization or we can use multiplication of conjugate. So I'll show you later on what do we mean by factorization and what do we mean by multiplication of conjugate. But this is a special case when we are having something with 0 over 0. Oh, by the way, 0 over 0 is not infinity. So that's the reason why we have some problem when we have 0 over 0. Okay, and then of course, the last one is that we are going to calculate a one-sided limit. So that means we either calculate the limit as x approaches a. So if you have a plus, it simply means that we approach from the right-hand side. So a plus will mean the right-hand side. If we have a negative, that will mean the left-hand side. So the limit as x approaches a from the right-hand side for fx is equal to L, and then the limit for x approaches a from the left-hand side for fx is equal to M. So we are going to calculate that one-sided limit. Okay, so now definition of limit. What do we mean by limit? Okay, so a function fx is said to approach a constant L as a limit when x approaches a as below. So the limit as x approaches a for fx is equal to L. So this is the way we write down our limit. Limit x approaches a. So do make sure limit x approaches a should be below the limit. The function on the right hand side equal to L. Okay, so where f is actually the function which assume a corresponding set of values and x is an independent variable. Okay, so a key point with the limit concept, so the concept of this limit is that we are not interested in the value of fx when x equal to a. We are only interested in the behavior of the function as x come closer and closer to a value of a. Okay, so now for example, determine the limit for x approaches a for x squared plus with 1. Okay, so if let's say we draw a table, so one for x, one for fx, like what we said earlier, we are interested with the behavior of our fx when the x are much more closer to the value of a. Over here, a is 0, so that means we want to see as x approaches 0, what will happen to the value on the right hand side and what will happen to the value on the left hand side. So you can easily try to substitute the value as x approaches 0 from the left hand side. So if you substitute negative 1, you get a 2. You substitute negative half, you get 1.25. You substitute negative 0.25. So this is negative 1 over 4, a quarter. So 1.0625. You substitute negative 0.001. It will become 1.00001. If we go approaching 0 from the right hand side, you substitute 1, half, a quarter, and 0.01. What can we see is that as we go much more closer to 0, we are going to get 1. So you are approaching x equal to 0 from the left, approaching x equal to 0 from the right. And you can easily see that when you draw your graph, on the left hand side, we are approaching 1. On the right hand side, we are also approaching 1. So the closer x get to the value 0, the closer the value of fx comes to 1. This could have been determined by simply substituting x equal to 0 into fx. So we can see that the limit as x approaches 0 from the left hand side for our function x squared plus 1. This is actually the limit as x approaches 0 from the right hand side of x squared plus 1, which is simply equal to 1. So kita just nak cakap bila kita approach daripada kiri, approach daripada kanan, kita boleh nampak nilai y kita tu akan sama dengan 1. Right. So the easiest way to calculate the limit is this one. It can be easily be determined by substituting the value of x equal to 0. Okay, so now properties of limit, there are a few properties that we need to know. The first one, if f of x equal to k, so k is some constant, then that means the limit as x approaches a for fx, which is the limit as x approaches a for a k, this is simply equal to k. So for example, if let's say we have the limit as x approaches 2 for let's say 5. So the limit for x approaches 2 for 5. So this is simply equal to 5. There is no x to substitute, so we can easily get a 5. Can you see? I think better for me to use white color. Okay, let me write them down again. Okay, so the limit as x approaches 2 for a 5. So this is immediately equal to 5. Okay, so now the second one. If fx is equal to x, then that means the limit for x approaches a for fx. So this one, you shouldn't write them down over here. It should be here actually. So the limit as x approaches a for fx. This is the limit for x approaches a for x. So we simply replace fx with x. So now substitute the value x with a, we are going to get a. So that means if let's say you have the limit as x approaches 3 for x, this is simply equal to 3. So we simply replace the x with 3. The third property is that if fx is equal to x to the power of n, where n is a positive integer, therefore the limit as x approaches a for fx, this is the limit as x approaches a for x to the power of n. So simply replace the x with a. So we are going to get a to the power of n. So if let's say you have the limit as x approaches 1, let's say we got x to the power of 4. So substitute x with 1, we are going to get 1 to the power of 4. So this is simply equal to 1. Okay, so done with the third property. So let us go to the next one. Okay, so if k, a, and b are real numbers, and the limit for x approaches a for fx is equal to a, and the limit for x approaches a for gx is equal to b, then if we have the limit for x approaches a for k fx, what can we do is that since k is simply a constant, we can actually factorize the k out and simply take the limit for x approaches a for fx. And since I know the value is equal to a, so that is how we get k times with a. Right, so if you have the limit for x approaches a for fx plus minus with gx, so what can we do is that we can actually separate the limit into two. So it will become the limit for x approaches a for fx plus and minus limit x approaches a for gx. So this one on the left hand side, we already determined them earlier. This is a. Meanwhile, this is b. So that is how you know it's supposed to be a plus minus b. Right, so now number 6. If let's say we have a limit for x approaches a, fx multiply with gx. So we got a multiplication over there. So we got a function f, a function g. So what can we do is that we can actually separate the limit. So it will become the limit for x approaches a for fx multiply with the limit as x approaches a for gx. And then since this one is equal to a, this is equal to b, so it's supposed to be a multiply with b. So now this is number 5, 6, 7. So 7, delete for x approaches a, and then now instead of having a multiplication, we have a division. So we have fx over gx. So do make sure to separate them. So you got to find out what is the limit for our numerator and calculate the limit for our denominator. So calculate the limit for our numerator. So this is the limit for x approaches a for fx, which is simply equal to a. And then the limit for x approaches a for gx, this is equal to b. But one thing you must know that if you want to calculate them, then the b value cannot be equal to 0. Otherwise, we are going to have infinity. Okay, so now let us go to the example. Okay, so the first one, find out the limit as x approaches 3, 4, 5. And then B, find out the limit for x approaches 4 for x. And then C, find out the limit for x approaches 4 for x to the power of 3. Okay, so I'll give you 2 minutes for you to calculate what are the limit for A, B, and C. Once you know the limit, you can simply write them down in the chat form. So kita boleh letak koma lah untuk A, B, and C. So I'll give you 2 minutes starting from now. Please calculate what is the limit. Oh, dah dapat dah. You found 5, 4, 64. Okay, so let's see. Orang lain? Okay, dapat juga. Dapat Miss. Okay, Alhamdulillah kalau dapat. Okay, so let us check your answer then. And let us see whether do you get the same answer with mine or not. Okay, so limit as x approaches 3, 4, 5. So that is simply some constant. So we're going to copy down the constant. So that is equal to 5. So correct everyone. And then B. So the limit for x approaches 4 for x. So we simply replace the x with 4. So it will become 4. So this is also true. Oops. Tiba-tiba dia macam padam tak? Straight. Sama je lah. Terima je lah, whatever. Okay, so the limit as x approaches 4 for x cube. So simply replace the x with 4. So we got 4 cube. So 4 cube is actually 64. So well done everyone. So siapa yang dapat betul, tahniah. Okay, next. Okay, so example 2. Find the limit for the following. So we got B, A, B, C, D. So perhaps I'll do question A and then you guys will do B, C, and D. Okay, so A, we got the limit as x approaches 2 for 5x cubed. Okay, so now take out the constant. So we have one property over there. If we have a constant, we can actually take out the constant. So 5, and then we're going to find out the limit as x approaches 2 for x cubed. Substitute the value for x with 2. We are going to get 2 cubed. So 5 multiplied with 2 cubed. 5 times 8. So this is actually equal to 40. Okay, so now we got another 3 questions for B, C, and D. So just in case you couldn't see the answer, so let me go back. You couldn't see the question, not couldn't see the answer. So let me go back to the question. So please do B, C, and D. Again, I'll give you 2 minutes for you to calculate them. So 2 minutes starting from now. Okay? Tak okay? Okay. Semua orang okay kah? Dapat jawapan kah? Oh lupa, hari ni tak pegang pun. Okay ke kalau tak pegang? Tak tahu. Saya tengok. Saya lupa nak buat setting saya sini. Tapi kalau dengar clear je okay lah. Okay kot. Cuma tak berapa dengar sangat. C tak dapat. Okay, tak apa. Oh, by the way I normally write down limit. So, biasanya saya suka pakai macam ni. L yang macam liter tu. Tapi tak jadi masalah pun. Nak pakai yang ini pun boleh je. Okey je. Cuma sebab tulisan saya bulat-bulat. So, saya suka yang macam ni sikit. Kenapa? Saja. Dia nampak macam style sikit. Sampailah. Okay, so let me go to B then. Okay, so B, we got a limit as x approaches -1 for x cubed minus with 10. So simply replace the x with -1. So we are going to get -1 cubed minus 10. So -1 cubed is -1 minus 10. So this is -11. Okay, so that is B. So let me proceed to C. Okay, so C, we got the limit as x approaches 4 for x squared. Multiply with x plus 1. So you can actually separate them into two. So firstly, calculate the limit for x approaches 4 for x squared. And then calculate the limit for x approaches 4 for x plus 1. And then you simply multiply them together. Okay, so multiply the limit for x approaches 4 for x squared. So substitute the value of x with 4. So we are going to get 4 squared. Substitute the value of x over here with 4. We are going to get 4 plus 1. So it will become 4 squared multiplied with 4 plus 1. So 16 multiplied with 5, which is simply equal to 80. So kalau nak expand dulu pun tak ada masalah. You can actually expand them first before you apply the limit. So normally for me, I do prefer to do that as well. So sometimes I do prefer to expand them first before I apply the limit. Okay, so that is for C. D, the limit as x approaches -5 for x over x squared plus 10. So we are having something with a division. So we're going to separate the limit. So substitute or find out the limit for our numerator and find out the limit for your denominator. And then we're going to combine them together. Okay, so separate the limit. So we got the limit as x approaches -5 for x, and then the limit as x approaches -5 for x squared plus with 10. So simply replace, whenever you see x, replace the x with -5. So it will become -5 over -5 squared plus with 10. So simplify them a little bit, we are going to get -1 over 7. Why -1 over 7? This is actually -5. And then we got 25 plus with 10. So this is actually -5 over 35. So that is how we get -1 over 7. So do make sure to leave your answer in the simplest form. Mesti dalam bentuk yang paling ringkas lah. The simplest form. Okay, next. Right, so find the limit using factorization and multiplication of conjugate. Okay, so if the solution for limit of rational function is 0 over 0, so that means we have a fraction. So we have something like the limit as x approaches a for fx over gx. So if you have a fraction, you're definitely going to separate your limit. So we're going to solve our numerator, we're going to solve our denominator, and then when you solve them, all of a sudden you get 0 over 0. So when you get 0 over 0, we cannot simply say it is equal to 0 because 0 over 0 is not 0. Therefore, we need to simplify the fraction by either using factorization, or we can actually multiply with a conjugate. So multiplication with a conjugate, so this one is normally belong to a set. So if you have a set, you get 0 over 0 and you do have something with a set, then you might want to multiply with the conjugate. Otherwise, you might want to factorize them. Alright, so the main reason why we are doing factorization or multiplication of conjugate is that we want to get rid of the term that will give us 0 over 0. So whenever we do factorization, we should be able to cancel out some terms. So mesti ada benda yang boleh cancel di bahagian numerator and denominator. The same thing will happen when you multiply with the conjugate. You should be able to find out something that can be cancelled out in your numerator and your denominator as well. So those terms are the thing that will give us 0 over 0. So once we get rid of them, we can easily get some value. Okay, so now factorization method. So for example, if let's say we want to find out the limit as x approaches 3 for x squared minus 9 over x minus 3. Okay, so how do we factorize them? Obviously, if you want to factorize, it's supposed to be something with the square. So factorize x squared minus 9. So 9 is actually 3 square. So you can easily factorize them. So it will become the limit as x approaches 3, x plus 3, x minus 3 over x minus 3. Right, so one thing that you should keep in mind, you are factorizing them, you haven't calculated the limit, so do make sure don't get rid of the limit yet. Not yet. Once you substitute with the value, then you can get rid of the limit. Otherwise, keep the limit. We haven't calculate them yet. Tapi bila kita dah ganti je nilai X masuk dalam tu, kita terus buang perkataan limit kat depan tu. Before that, you should keep writing down limit until you substitute the value in. Okay, so firstly, before you decide to either doing the factorization method or not, actually we should try to substitute first. So if you substitute with 3, you got 3 square minus 9. So this is actually 0. If you substitute 3 over here, so 3 minus 3, this is also 0. So since we have 0 over 0, that is how we know either we want to do factorization or we want to multiply with the conjugate. So obviously this one should be factorized. Nampak tajuk kat atas pun dah nampak kan, factorization method, obviously factorize lah. Okay, so factorize them completely. So it will become x plus 3, x minus 3, x minus 3. Now cancel out x minus 3 and x minus 3. So cancel these two out. You will be left with the limit as x approaches 3 for x plus 3. So do you remember what did I say earlier? Bila kita buat factorization, mesti kita akan cancel out term yang bagi kita kosong per kosong. So now you can easily go ahead and substitute the value of 3 in. So it will become 3 plus 3, which is simply equal to 6. Okay, so now why we can easily cancel out nilai tu, because the limit we simply approach the number, so the number itself is not 0, so that is why you can easily cancel those two. Okay, so I got the answer for this one, so let us move on to the next one. Okay, so multiplication of conjugate method. So this is example 4. Find the limit of the below one. So the first one, we got the limit as x approaches 1 for square root of x minus 1 over x minus 1. Another one is the limit as x approaches 1, x minus 1 over the square root of x minus 1. Okay, so first thing first, substitute the value first. Okay, so if we substitute with 1, we are going to get set of 1 minus 1, which is simply equal to 0. Substitute 1, 1 minus 1, that is also 0. So we do know that we must either factorize or conjugate. So how to know whether to factorize or conjugate? The first one, obvious, subject, conjugate. Second one, you should be able to see you have a set. So once you have a set, that means you need to times with the conjugate. Okay, so if we go to the second one and you simply substitute x with 1, so 1 minus 1, this is also 0. Substitute 1 over here, so square root of 1 minus 1, that is also 0. And again, we got 0 over 0, so that means either we factorize or multiply with conjugate again. So factorize or conjugate? Obviously, you have a set, so that means this one we also times with the conjugate. Sebenarnya kalau nak factorize pun tak ada masalah, boleh je kalau nak. Okay, so for conjugate, it's not necessarily need to be in your denominator. So bahagian set ni tak semestinya bahagian denominator lah. So numerator boleh, denominator pun boleh. As you can see for this part, this is in my numerator. For the second part, that is actually in our denominator. Okay, so don't look at the answer yet. You got to try to do them on your own. So I'll give you a few minutes for you to try them a little bit. Okay, so saya bagi masa dalam 3 minit ke for you to look at the answer. Because if I'm not mistaken, diorang dah terus bagi answer kot. Tak sengaja. Okay, so do look at them and then see what happened and how do you multiply and so on. So kena try buat sendiri ya, jangan tengok je. Okay, so try to do that. In the meantime, let me see how many slides do we have left. Bunyi apa tu? Bunyi saya rasa lah. Saya rasa orang ketuk dinding weh. Saya rasa lah. Construction eh. Kuat sangat bunyi dia. Kalau kuat sangat nanti saya suruh dia buat construction waktu lain, suka hati aku je. Okay, so okay dah ke? Boleh. Right, so now let us continue then. Okay, so the limit as x approaches 1 for square root of x minus 1 over x minus 1 equal to, okay, so we're going to times with the conjugate. So multiply with square root of x plus 1 over square root of x plus 1. So you times them first. So it will become x minus 1 over x minus 1 square root of x plus 1. Okay, so I'll give you one tips. If you multiply something with the conjugate, do make sure only if you times the conjugate together with itself, then you expand. That means only the term with the set times with its own conjugate, then you expand and simplify them. Otherwise, simply leave them inside a bracket. So kalau kita bukan multiply dengan conjugate dia sendiri, kita tinggal saja dalam kurungan. Okay, so now this one is the conjugate of this one. So that's the reason why I times these two. So that is how I know this is x minus 1 over x minus 1 square root of x plus 1. And then, of course, you should be able to see there are actually something that can be cancelled out. So that is actually our aim, either to do factorization or multiplying with the conjugate. We simply want to cancel out the term that will give us 0 over 0. So cancel those two. We are going to end up with the limit as x approaches 1 over square root of x plus 1. And then replace the value of x. So we are going to get 1 over z1 plus 1, which is simply equal to 1 over 2. Okay, so that is for the first one. Let us proceed with the second one. Okay, so this is the limit as x approaches 1 for x minus 1 over square root of x minus 1. Like I told you before, we're going to multiply with the conjugate. So we're going to times with square root of x plus 1 over square root of x plus 1. And I give you one tips already, right? So only if you multiply with its own conjugate, then we expand. Otherwise, we don't expand them. So for example, these two, they are the conjugate of each other, then we expand. These two, they are not the conjugate of each other, so I'm going to leave them inside a bracket. Okay, so what do we have is x minus 1 square root of x plus 1 over x minus 1. So do remember you haven't substitute the value of x yet. So keep writing down the word limit. So we do see something that can be cancelled out. So x minus 1, those two will be cancelled out. So we are left with the limit as x approaches 1 for square root of x plus 1. So now you can easily replace the x with 1, so get rid of the word limit itself. So we got square root of 1 plus with 1. And square root of 1 is actually 1. So 1 plus 1 is equal to 2. Okay, so done with this. So do remember, if you have 0 over 0, you have two methods. So you can either factorize or you can multiply with the conjugate. Okay, so now let us talk about the last learning outcome where we got to learn about one-sided limit. Okay, so what do we mean by one-sided limit is that before this, we are simply doing the limit for x approaching a number. So we didn't really say whether is it approaching a number from the left-hand side or right-hand side. Okay, so now we want to see either from the left or right-hand side. Okay, so from this graph, you can see that this is the value for x equal to 0. So we notice that fx approaches 0 as x approaches from the left hand side. So from the left hand side, this value, we are approaching the value of y equal to 0. Meanwhile, if we are approaching x equal to 0 from the right hand side, this value of y is actually 1. So a one-sided limit, it can either be the right hand limit or the left hand limit. Okay, so if I want to write them down, so for example, this one, this is actually the limit as x approaches 0. So I'm approaching from the right hand side. So this is 0 with a plus. So I'm not sure the function yet. So I'm simply going to write down fx. For the graph, the limit for x approaches 0 from the right hand side. So this is equal to 1. Based on this one, this is the limit as x approaches 0 from the left hand side for fx, and this value is actually equal to 0. Okay, so we can either have a right hand limit or a left hand limit. Okay, so right hand limit, so this is the limit as x approaches a. So do make sure to write a plus for them. So we are approaching from the right hand side for fx, and once we substitute the value of the a inside the function, we're going to get L as the subject. So the limit of f as x approaches from the right hand side, as x approaches a from the right hand side, is L. For left hand limit, when the way we write them down is the limit as x approaches a do make sure to write down a minus on top of a, fx, and this is actually equal to m. So the limit of f as x approaches a from the left hand side is m. Okay, so this is the last example, example 5. Evaluate each of the following limit. So the first one, calculate the limit as x approaches 2 from the right hand side for x cubed minus 2x plus with 7. And then another one, the limit as x approaches 5 from the left hand side for x minus 5 over x squared minus 25. Okay, so perhaps I'll give you around 5 minutes for you to do A and B. How to do them? We simply substitute them in. Masuk je nilai. Five minutes to think little bit. If you have your answer, you can easily write down your answer and then we're going to check them later on. So kalau dah ada answer, boleh tulis answer eh? 11, 1/10. Betul lah. Amirul Mukmin. Betul. Jawapan tu. Muktamar. Tak nak tukar lah. Tak sure. Boleh lah. Mereka tak sure. Yang lain? Are you guys doing good? I think the concept of the limit is quite new to you guys. So that is the reason why I go a little bit slow for the first lecture. But next week, we got to go a little bit fast actually next week. So today, this is quite new. So we go a little bit slow. For next week, it's going to be more fast. Let's see, where is everyone? Are you guys having your lunch? Um, okay, so now let us evaluate each of the following limit now. Okay, so Pong pun ada. Hi Pong. 11, 1/10 juga. Okay, let us check. Okay, so now the limit as x approaches 2 from the right hand side for x cubed minus 2x plus with 7. So basically we're gonna substitute the value of x with 2. So we're gonna get 2 cubed minus 2 times 2 plus with 7. So we got 8 minus 4 plus with 7. So 8 minus 4, 4, 4 plus 7. So that is actually equal to 11. So very good. We got 11 over there. So this one done. B. So the limit as x approaches 5 from the left hand side for x minus 5 over x squared minus 25. If you simply substitute with x equal to 5, you will end up with 0 over 0. So 5 minus 5, 0. 5 square minus 25, that is also 0. So since 0 over 0, there are two methods to solve them. We either factorize or multiply with the conjugate. Okay, so since we don't see anything with a set, so that's the reason why I'm factorizing my denominator. So I will have x plus 5, x minus 5, x minus 5. And then as usual, whenever we are factorizing or multiplying with the conjugate, the aim is to cancel out the term that will give us 0 over 0. So you can easily cancel out the term that will give you 0 over 0. So we're going to cancel out x minus 5, x minus 5. So we will end up with 1 over x plus 5. So now substitute the value of 5 in. So we got 1 over 5 plus 5, which is simply equal to 1 over 10. So betul lah yang dapat tu. So tahniah. Okay, so I think that's it for this lecture. I'll see you guys in lecture 2 then. Okay, so I'll see you guys next week. Thank you. Enjoy your weekend. Goodbye, everyone. Have a nice day. Bye bye.